Next up, I'm going to show you how to solve the ALEKS problem, cyclohexane substituents. What ALEKS is going to ask us here is complete the given shear conformation of a cyclohexane by adding a listed substituent to the specified position and bond direction. So what ALEKS is going to do here is it's going to show us a cyclohexane. Let me go to my marker real quick, which is right here, this structure here. And then what it wants us to do, and it's going to have it labeled with 6 different numbers, and it wants us to pretty much draw out the cyclohexane with the 2 substituents that we have listed right here in the position that they have. So this is a fairly simple question. Just follow my tips on this one. The first one is that for axials on the left and the right, they will face upwards. So what I want you to imagine here is I have a cyclohexane with CH3, and on this cyclohexane, every position is the axial position. So for the ones on the left right here, as you see, they're facing upwards, and you'll develop your tricks as you go throughout it. And the one right here is facing outward, downward. And then on the right-hand side as well, going axial is facing upwards and then downwards. And then the 2 that's in the middle, or the 2 that's in the middle that are axial, the one that's in position number 3 is going to go up and cross the molecule. And the one that's in position number 6 is going to go down and cross the molecule. So kind of fairly simple on that one. And then the next one is, it can show us a substituent or so that is equatorial. And so by equatorial, I also drew out kind of the model of them all. So pretty much on the one that's on the far left and right, they're going to be facing outward. So this kind of help y'all get like a direction. And then the 2 spots that are in the middle, so say in this case, position 3 and number 6, they're going to be facing, they're not going to cross the molecule, and they're going to be facing like outward. So this position 6 is going to go up this way, and position 3 is going to head out this way. So we're going to erase these real quick, and then I'll show you how to quickly solve. So going right back to my model real fast, kind of the other free tip I have is just feel free to screenshot both models. The one with on the left is one where the CH3 is all axial, and then the other one is where CH3 is all equatorial. And then kind of that last key tip that I put on there was for the CH3s that are on the left-hand side, or really any molecule that's on the left-hand side that's equatorial, it's going to go backwards. So instead of CH3, you're going to write H3C, and that's just the way that ALEKS like to see it. Because again, in one of my other videos I shared, if you was to write CH, ALEKS, that means the line will be connected to the hydrogen, which is what ALEKS don't want. So preferably it wants you to write the line out here, and then it wants you to write C and 3H. That way the line is connected to the carbon. All right, I'm going to go ahead and erase this real quick, and then we're going to solve. So looking at the compound itself, it's showing us 2 substituents, CH3 and OH. And I see for CH3, it's going to be on position number 6, so right here, and it's going to be equatorial. So what I can do is I can go to where position 6 is right here. I'm going to first pick which model I want. So because I have one that's shaped this way in this structure, I'm going to click here on ALEKS, and I'm going to select the one that's like this. And next up, I'm going to see where position number 6 is on the molecule. So it'll be located right here. And then what it wants me to do in position 6 is to write CH3. So I'm going to just send the line up like that. And I'm going to go CH3. The next one, it wants me to do OH. And OH is going to be in position number 2. So right here to the left. And it's going to be axial. And I'm going to look right here, and I see the axial is going down. So I'm going to go down and CH. Oh, no, sorry. I got the wrong molecule on there. I'm going to write OH. And this would pretty much be right in ALEKS, so you'll get it right if you just follow and solve this method. Now, again, I have a different one on here just so you can kind of see if you had like a different shape cyclohexane. So you'll, again, go back here. You'll select the cyclohexane, and you'll just follow the same system. So number 6 is equatorial. So I see that I got position 6 here, which matches up to right here on my sheet that I have here. And it has CH3, so it matches up kind of with what I already put below. So I'm going to come right out here to where position 6 is. I'm going to draw the line here. And again, I'm not going to write CH3 because the line will be connected to the hydrogen. So instead, I'm going to write H3C. That way that the line is connected to the carbon. And again, that's just the way that ALEKS like to do things. Next up, I see that I have OH on position number 4, and it's going to be axial. So I'm going to circle position number 4 right here. And then what I'm going to do is I can look out at my axial, and I see that on position 4 axial, that it's going to go in the upwards direction. So I'm just going to write a line up right here. And then I'm just going to write OH. So again, fairly simple. You can just follow the system that's here on the question. Just remember for equatorial, when it's for the ones on the left, if you have like CH3 or so, you're just going to write it backwards. So that's kind of the big tip that be catching students up. But for the rest of the compound, you're going to write it normal, no matter what position it is. But when these two right here are equatorial, you're going to write them backwards. But again, this is fairly simple. Just take time to practice. You develop your systems and your tricks for it. Like one of my earlier tips was if it's on the line for axial, it's just going to face up. And it's just on you to kind of learn your positions. But again, if this video helped you or your classmates, feel free to like, share, and subscribe to the channel. Thank you.